Because it was actually.
Okay. So let me rewind a little bit. Graphs can show the differences between quantities without specific numbers on the axes. We look at this graph, you're doing distance over time. So that little section of graph that's where it's completely flat shows that you're not moving because your distance isn't changing. Okay, that shows you're not moving. Go ahead and write that down right there. You're not moving. You might have a test question where they throw two graphs up side by side and say, what's the difference between these two? Okay. So then when I look at this one here, we looked at this little flat portion right there. That doesn't mean you're not moving because they've changed what the y-axis is labeled in. It's labeled as your speed. It doesn't mean that you're not moving. It means that your speed's not changing. But since you're going, like on this graph, not moving means right there, my speed 0. But in this graph, my speed is, I don't know, 20. I don't know what it is. It doesn't say what it is, but you're going the same rate. It just means you're cruising. There's a difference between not moving, where it says distance over time, and this one which says speed over time, and this one just shows that you're cruising at that same speed for a while. Yeah, Caleb?
So on the fourth graph, that on the bottom line,
Yep.
there's like not a blue line. So does that mean where you're going 0?
Yeah, so for this one here, you really aren't moving. Like in order for it to be not moving on this one, it has to be, that flat piece has to be on bottom because you're checking your speed.
So
Yeah, this would mean you're not moving because your speed is staying 0. Whereas up here, because you're doing distance over time, this meant your distance wasn't changing because you're not moving. And so it just depends on what your y-axis is labeled in. Okay, and we'll look at that again. I think I've got a question here at the bottom of your notes.
In that graph,
Okay, all right. So for the first one, you gradually increase your speed. We know that it's not graph B for that because graph B doesn't start with us gradually increasing our speed. Then you ride at a constant speed. Okay, that doesn't look like a constant speed. You're just driving a faster speed. This one starts having you decrease speed. So automatically know this has to be graph C. So actually, I'll just put A up here. Probably the easiest way. It says then you slow down and you reach your friend's house, and obviously you're going to stop when you reach your friend's house and you're slowing down. So this has you increasing your speed, staying the same speed, and then decreasing your speed. So that's going to be scenario A. Okay, now let's read scenario B. You gradually increase your speed. So it's either A or D, first or last graph, I should say. Then you go down a hill. Now what's going to happen as you go down a hill? You're going to go faster. So which graph has you going fast and then going faster?
that one, right there.
The first one.
No, A is that one.
No, it's not deep, but like this.
No. Yeah, you're going downhill. And what's happening to your speed as you go downhill?
You go faster.
Yes. So this is not a graph of my elevation. It's not saying height. Okay. It's graphing my speed. And so this shows my speed going, increasing and then sharply decreasing. Whereas if I go down a hill, I know that actually my speed's going to rise. My speed's going to go up unless I'm braking the whole time. Okay. And then it says you quickly come to a stop at an intersection. So your speed decreases until you come to a stop. All right. You gradually increase your speed. Huh? Done. It's the only one that's left. All right. You gradually increase your speed. You stop for a couple of minutes. As we mentioned, this shows you stopping at for a couple minutes. Your speed is 0 as time's passing, so you're not moving. And then you gradually increase your speed again. So graph C, or scenario C, would be our last graph there. And then that makes this graph D. Let's go ahead and read what it says. You ride at a constant speed. Yep, there's our constant speed. Then you go uphill. Okay. Yes. Going uphill means your speed is going to decrease because you're going against gravity. Once you get to the top of the hill, there's no stopping. You start going down the hill, so your speed's going to increase. Okay. All right, so there's our different scenarios. And you can see I didn't have to do any work there, which is why you don't have a work paper for the 6.5 homework. Next one, the graph represents the heights of a rocket and a weather balloon after they are launched. One of them has a linear part to it, it's linear, and the other one's non-linear. If you had to guess, which of those two scenarios would you say is the linear one, Levi? The rocket's the linear one?
The air balloon.
The balloon, and so a weather balloon is just, it's bigger, it's got a lot of helium in it. And so I want you to imagine, Levi, letting go of a balloon. It's gonna start taking off, right? Have you ever let go of a balloon before?
No.
Okay. You can't, after you let go of it, you can't reach it again because it starts taking off and then it continues at that same speed up, 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 up. Whereas if you watched a rocket take off, it starts off very slow and then it builds its speed as it starts going up, it starts getting faster, okay? And so graph A would be the rocket graph.
At the end of that, it's just like all the way down.
All really down.
Okay, again, hey, this is not a graph of its elevation. Okay,
Yeah, it is.
No, yeah.
actually it is. You're right. I guess what I meant to say, the y-axis is asking about height. The graph is actually of its speed. Okay, so it really isn't a graph of elevation, even though elevation is part of it. When I look at elevation and time, what I'm seeing here is how quickly these were taking off. So this one is the balloon.
So like elevation plus height.
Thousand.
In this.
No. No. Okay. It wants us to do three different things. It says, how are the graphs similar and how are they different? Give me one reason these graphs are similar. Ashton? Similar.
Oh, similar. Sorry.
I'll come back to you. Okay, well then I won't come back to you. Okay. So both are increasing. Another way of saying that is both have positive slopes, correct?
Yes, sir.
Okay. But as you just said, as Ashton just said, one of them's linear and one of them's nonlinear. So they both have positive slopes, but one of them's got a constant slope. This one would be a constant rate of change. Did I?
Yeah, it's yellow.
Oops. There you go. So one of them's got a constant rate of change. The other one has a variable rate of change, which means it's changing. The rate of change is changing. Okay. And so I like his definition or his explanation of saying one's linear versus one being nonlinear. That's definitely a way that they're different. Now, in this section, we actually have a name for the kind of graph you're looking at in graph A. Graph B is linear, right? And it has a constant rate of change. Graph A, instead of saying that it's just got a variable rate of change, variable means that it changes. And there's a way that they actually say that this one would change. Devin, you know what it is? Oh, sorry, not the name of the graph, but how, instead of saying variable, they're going to have a different way of you describing how this one's changing. Vijay? Yes. So I want you to write that down. It's increasing. It's increasing at an increasing rate. And so what that means is it's increasing the whole time. We know that, right? But the rate of increase starts off increasing very slowly, picking up speed, picking up more speed to the point where, you know, if I split this time graph into 4 different parts, there's the first fourth, it didn't really go anywhere. Here's the second fourth, okay, it picked up some speed. Here's the third fourth, okay, yeah, a lot different. And then if you look at the last fourth, there was a lot of change in that section of graph. So it's increasing its speed at an increasing rate, or increasing at an increasing rate. Whereas this one, we would just say this one has a constant rate of change because it's linear. So you are going to need to know that what increasing at an increasing rate looks like. Okay? Compare the steepness. We just said that. One is increasing at an increasing rate. The other one's constant. And it says, which graph do you think represents the height of the rocket? We've already said. So we've answered all three of those. Good check. I will look at that later. Don't jump ahead.
Come on.
Caleb.
Oh, never mind.
Okay. Next one. The graph represents the speed of two cars. One car is approaching a stop sign. The other car is approaching a yield sign. Now, you may not know what a yield sign is. Those are triangular.
I've seen a lot.
Okay. Do you have to stop at a yield sign?
No, but it's
No.
advised that you slow down.
Yes, means yield means you're slowing down, and to yield means you're basically, the word yield kind of like a word means surrender almost. You're almost surrendering, because if you're yielding, that means the other lane has the right of way. So if I'm making a right turn, you can actually turn right on red. Now that's a little bit different because you're supposed to stop first, then turn right. Okay. But if you get to what would be a good way of describing? So there are some intersections where if you've been down in the Westfield Carmel area, they got all those traffic circles,
Yeah.
those roundabouts. And instead of getting on the roundabout, there's actually, if you're turning right, there's some that just curve and they kind of swerve away from the roundabout and just get on. And there's a yield sign there. In fact, all the roundabouts have yield signs as well. Okay, and so it doesn't mean you have to stop, but you do have to stop if another car's coming and you can't merge onto that. So that's what yield means. And so I guess what I'm trying to say is that you don't necessarily have to stop. And if you don't have to stop, then that means graph A would be the one that you're yielding. Okay, because your speed never goes to zero, so you're never stopping. So this would be the yield.
Is that decreasing?
Then stop it.
And this one is, yeah, this is the car that's stopping, or stop sign. Now it has a constant rate of change, just like the last line we looked at. This one is also a variable rate of change, graph A, but as you guys have said, this one is decreasing at a decreasing rate. Decreasing because it has a negative slope, just like the other one, but it starts off decreasing very quickly and then starts to slow, the decreasing starts to slow down. So it's decreasing at a decreasing rate. Okay. There is a graph that is decreasing at an increasing rate. There's also one that's increasing at a decreasing, and we'll look at those too. Okay, get the hood off your head. All right. How are the graphs similar? Caleb? Caitlin? Negative slopes. I like it. Yep. Both are slowing down. That's what negative slope in this case means, right? Because you're doing your speed. So both of them are slowing down. So you could put either that negative slope or slowing down. So that's one way they're similar. Put an S next to that. And one way they're different. Mm-hmm. In fact, I'm going to go back up to the last one for those that are, so this would be the one they were the same. This would be one way that they're different. Yeah, we've already compared the steepness. We said one was constant, one was decreasing at a decreasing rate, and we know the stop sign would have to be the second one, and the yield sign would have to be the first one. Okay, does everyone have all that written down? We didn't write too much. I answered the questions mostly verbally. Camden, would you shut that door for me, please? Max? Never mind. All right, next one. Next one says, what could this graph represent? I'm going to give you 2 minutes, and I want you to write down or type whatever you want to do, a story. Any story you want that has to have 4 parts to the story. One representing each of the four parts of that graph. Now you're doing distance over time, not speed over time. And so you get to decide, what is this distance from? You're obviously starting at 0. So if it's distance from home, then you're starting at home. If it's distance from school, you're starting at school, because your distance to start this graph at is at 0. So there's no difference between distance between you and where you're starting. And so whatever your story has to have that part to it, has to have a part where you are moving or not moving. Not moving. So there's a part where you stay put, for a little bit. And then your distance is going to increase again. And then ultimately you're going to return back to your starting destination. So take 2 minutes and jot down a story or scenario that goes along with that graph. I don't need to hear it.
So I have a question.
Sure,
When you say you're not moving to like a flat line, does that mean your speed is zero?
correct. Yeah, if it would have said, if this would say speed right here, that means this would mean you're still moving. You're just not increasing or decreasing your speed. So you hit cruise control, I guess is what it means. But if it says distance, then that really does mean you're not moving. Because your distance isn't changing. Camden?
If I get up into different days, like.
No, same day.
Can you remind me of those?
So
Sure.
if technically, this is just moving forward and backward, right? So technically, if you're moving side to side, but you're staying like in the same like place forward and backwards wise, would that be counting as like a flat graph?
Moving side to side.
Like this. Like this one.
Yeah, like what if you?
It
stop
probably
and
wouldn't work for this story.
If you stop moving forward, I'm just saying like in a different scenario, you stop moving forward, but then you move like side to side, but you stay in like the same place forward and back.
And your distance isn't changing, yeah. In that scenario, they would just say you're not moving. Like if you had a GPS in your phone and I was searching where you were, it's gonna say you're in the same spot, right? Because you haven't gone anywhere, although you took a step to the right, step to the left, you haven't moved anywhere.
Did you know?
So.
Yeah.
That's creepy.
Well, I mean, you're sending them your.
Did you know the
like,
FBI
we
watched
might be
you
thinking
your
about
phone?
send it like one time,
This is personal.
but then like they slow it down later, and it'll be wherever.
They can watch me through my phone.
That's why we're getting that sticker over here.
For people that put their phone in their back pocket, they're mostly watching your butt cheek, I guess, in the complete darkness of your back pocket.
I keep my. What if they have the other one? I see my phone in my front left pocket. In case you're wrong.
You're bleeding? You need a Band-Aid?
I put one in my right.
All right. So who's got one finished? Olivia.
Okay, Janet was riding her new bike. First, she rode up the hill, but there was a stop sign at the top of the hill, so she stopped for a second. And then she kept going up the hill. And then when she reached the peak of the hill, she went down.
Okay, your story does not work. Here's why. Your story, instead of doing distance over time, you did height over time. So you thought, which I was okay with your story until the part where you said she just went down the hill. Because unless she turned around and went down the hill, I guess if she started at home, she has to end the story at home.
It's a.
Because it's distance from home in your case, so she'd have to immediately turn around the bike and do that, which she could. But yeah, just because it goes up doesn't mean that your height is going up. This just means your distance from home is increasing, so you're going somewhere, and then you're staying there, and then you're going somewhere again, or you're going farther away, and then you're coming back. Okay, give it a shot, Callan.
Leave your house and you drive down the road for stuff. That doesn't change for a while. When you start driving, you pull up to a green light, somebody runs the light, so you can stop abruptly. So you don't hit them.
I also disagree with your story.
I agree with
Because your story starts at home and does not end at home. It has to end. Your distance from home starts at 0, and then at the end of the graph, it ends at 0. So if you would have said you were driving at a stoplight, you stopped for a little bit, I get that. That's okay, just like with Olivia's. Then you're driving farther away. You would have had to have said, then you immediately turned around and drove home. You didn't stop. You didn't like stop and get out of the car. You immediately did a turnaround.
360.
Got 180. And you drove back home. You have to have some element that goes back home.
I have a good story.
I thought it great.
Levi.
It's really fun.
Yes, you.
James starts at his house and runs 4 miles in 15 minutes to get to school.
Okay.
Gets there in 45 minutes. Then sprints 1 mile in 3 minutes to get to the hospital. And he runs 5 miles.
Okay,
What was the
that works.
time?
Levi, run.
Yo, he did this.
Shh.
Timmy can fly.
Of course he can.
Yes.
It's your story. Timmy can fly. Timmy can fly. All right. Shush.
And Timmy flew. And Timmy was flying up into the sky, straight up. And then he went to the clouds and stopped there, kind of looked around for a while. And then he went higher and hit a plane and fell down.
Okay. What's the distance from? Where'd Timmy start the story?
He started on like the sidewalk.
Mine works.
Okay. Where did he end the story?
Well, he fell back on the sidewalk.
Okay. Then I guess we'll count it. Madison Davis. Shh. I like it. John. Okay. One more. Big thing. I will, just not during class. Yes.
Then he starts walking and forgets his iPad.
Okay, I like it. I like it. Maybe during success time. Now, sit down. Sit down. Okay, here's another example story, and I'm going to say it because they weren't able to hear you guys very well. So here's an example story that would work. You're driving, your mom is driving you to baseball practice. Okay, so you're driving away from the house, baseball practice. She stops to get some gas because she didn't have enough gas in the car. So as that's happening, you're not moving. All right, time's still ticking, you're not moving. Okay. Continues on the way to school until Max all of a sudden says, "Mom, I forgot my mitt." Drive right back home. Okay. Now, there would be more to this graph, obviously. There'd be a part where it has me going and Mom dropping Max back off at school. But that would work for this. So if you have something, I'd love you to share it later. We're going to look at a couple more examples before I let you guys out of here. Well, not out of here, out of here to use the restroom, I suppose. All right. The graphs show the temperatures throughout the day in two cities. We've got Belfast, Maine, and Newport, Oregon. Cooper. Describe the change in temperature in each city. I've already heard from you. What's going on in Belfast? What's the temperature doing, Camden? Okay, let's describe this. It's increasing at a decreasing rate.
That was what Newshaven was asking about, right?
The temperature is increasing at a decreasing rate. Okay, until it stops increasing at all, obviously, at the top of the parabola, and then starts doing what? It starts
decreasing at an increasing rate.
You got it. Starts decreasing at an increasing rate. When it makes it around, the top of the parabola, it starts to slowly decrease until it starts to pick up and starts to decrease much faster because the sun's going down, and as the sun goes down, the temperature really starts to drop. What about in Newport, Oregon? What's going on there, Caleb?
It dropped, but it stayed the same.
Would you say it was a slow decrease or a rapid decrease? Okay, so the temperature is rapidly decreasing at a variable or constant rate?
Variable.
No.
Could you
Yes.
compare the stock market?
Sure. So it's rapidly decreasing at a constant rate because the first part of the graph is linear. Okay. Then it stays the same Okay, so nothing's happening to the temperature right there. And then would you say it slowly increases or rapidly increases?
Slowly, gradually.
Okay, slowly or gradually increases. Okay. Make 3 comparisons from the graph. They could be similarities or differences. Caleb,
They're both talking about weather.
I need something more math related than they're talking about weather. Devin.
One increases, then decreases, the other one decreases, then increases.
Okay, I like that. So one, I'm going to put one increases, then decreases. And then I would say the other
Vice versa.
or that, vice versa. Other decreases, then increases. Okay, I like that. Caitlin?
They both decrease at their point.
They both
They both decrease at some point.
Okay, so both, okay, I feel like I can say, well, I feel like that's what we said here, right? Both of them increased, both of them didn't decrease, just at different parts. He didn't.
No.
You could write that. I just feel like I've said that and I'll find something else. Ashton?
One is higher than the other at the end of the day. Oh, wait, no, never mind.
They actually,
Higher than the other.
they actually end at the same temperature.
Same thing.
Do they start at the same temperature?
No.
Okay, I could say that. Maybe that's what,
Wait, they had the same temperature at some point, but not at different times. Or not at the same time,
okay, they start at different temps,
camp.
but
but end at the same.
like, no, yeah.
Okay. How about let's look more at the middle of the day. All right. In the middle of the day, Belfast is hotter than it is at morning or night. At the middle of the day, Newport is colder. Okay. So Belfast is hotter midday, and Newport colder midday. All right, so before I dismiss you guys, and we'll finish these notes tomorrow, I want you to sketch, I guess scroll down to the bottom of your notes. I want you to sketch 4 different graphs for me.
We don't have an extra.
We don't have an extra page.
Write on it, and it'll add an extra page.
Oh, that's so cool, man.
All right, the first one I want you to write. Actually, I'll tell you what, it'll probably be easier. I'm gonna draw a picture, then you guys take, you guys take a picture and just add the picture. Okay? I'm gonna draw the picture on Notability, but if you don't wanna write it yourself, you can take a picture of my screen and add it. Okay, so here's the first one. Increasing at increasing rate. Okay, increasing at decreasing rate. Okay, so I'm going to draw a picture of what this would look like real quick. Okay. I need you to listen. If it's increasing at an increasing rate, it's going to look like this. Okay. I'll even color code it for you guys. Not the exact opposite. Okay. If it's increasing at a decreasing rate, it's going to look like this. I thought, by exact opposite, I thought you meant it was going to go down. Okay. Next one. And I'm going to actually shrink this to where they all fit on, all 4 of them fit together. The next one is going to be decreasing. I can write it. Decreasing at increasing rate. Okay, so decreasing at an increasing rate is going to look like this. Okay. Whatever you want. You're supposed to be taking a picture of it, so I'm not sure why it matters to you.
Oh, my God.
Yeah, but you said it's a picture of it.
And then we have decreasing at decreasing rate. And that's going to look like this. Well, yeah, we didn't actually see one of those. You know, hang on. Hang on. I'm going to shrink them down and make them all fit together so you can answer one picture. Okay, you can take a picture of that.
They're like super cool how it's all like.
There are going to be questions in the homework and definitely questions on the test next week that ask you to draw a graph of decreasing at a decreasing rate, decreasing at increasing, blah, blah, blah. So you'll want to know this. That's why I'm having you take a picture of it. When you've got your picture taken, I told you we're going to finish the rest of these notes tomorrow. Doesn't mean you have to wait on me to finish the homework, but I definitely want to talk about what we're doing in this. But I believe you guys can go ahead and use the bathroom.
Right? No, so like it being, I don't want to call it either.
No
It's
class.
just
You're
a
going.
notability. I'm not even like,
No, I know what you mean.
I think everything's just like, my iPad's just like.
If they've restricted